Um, Hello and welcome everyone. I wanna talk about this problem called Olya and game with arrays. Let's not dive deeper into the statements here. I will be explaining it exactly what they want us to find out by explaining this picture. Um, well, you are gonna be taking input a bunch of arrays. Let's say there are n number of arrays. And each and every array is gonna have variable number of length of each and every array. For example, this array is taking 8 length arrays. This is one, two, three, four, five, 6 length arrays, so on and so forth. This is 3 length, 1 and 2 length array. Now, what you have to find out is um, a value that will be the sum of some values, but each and every is sum of n values, as in for n number of arrays. So sum of n values. Now, what are each and every one of those n values? Those n values are going to be the minimum out of the existing array that's going to remain after you perform some operations. Now, what sort of operations that you're going to perform, I will talk about it later, but first understand what are we going to have to find out. A value. What is that value? How are we going to calculate? That will be the sum of n values, as in for n arrays. Each and every one of those values will be the minimum out of all the individual arrays. So for example, let's say this value you found somehow, this is the minimum. This is the minimum of this value, and of this array. Let's say this is the minimum of this array, so on and so forth. Now what you're going to do is simply you're going to sum those minimums, each and every one of those arrays. Now you have to find this value and you have to make it as maximum as possible by following an operations that you can perform in each and every individual arrays. What is that operation that you can utilize to finally get a value that is as max as possible? What is the operation? The operation is basically you take at most you can take at most one value from each and every one of the arrays, and you can take that value from that array and you can input into any other array. So for example, you can perform an operation. Let's say there is a value called 6 and you want to pick that 6 and you can add it here. So that comes to here, and that comes, the 6 is now gone. This position is now gone. So that's going to be the operation that you can perform, but the condition is that at most one value from each and every array that you can take. That does also give us a hint that you can take at most one value from each and every array, and you add it any of the section, any of the other arrays. And also it is said that any array can actually take any number of values as an input. So for example, this value you pick, you add it here. This value you pick, you add it here. It doesn't matter how many times the array gets the value. You can you can add multiple values from different arrays into one specific one. But if you want to take one value, not take one value, then it's gonna have to be at most one value. You can either not take the value, or you can take a value, but it's gonna be at most one value that you can take. So that's the operation. Now, what's the best way to solve this problem? Remember what I said, at most one value from each and every array. Now this gives us a heads up on how we can actually solve this problem. Uh, because you can take at most one value of each and every array, what you can do is you don't actually have to worry about, if you think clearly, what you want those minimum values of each and every array as maximum as possible. So you um, you would always want to not take this value, each and every value of these arrays, as the very minimum one. You do not want that. That's the primary goal. Now, as you cannot take out more than one value from each and every array, you only would want to pick the one which is the minimum value from each and every array. You will try to do something like that. For example, let's say this is the minimum value of the array. You take that value because it's the minimum. It will contribute to the final result if you do not take it out. Because if you do take it out, you will have some value which is greater than this minimum value. As at most one value can be erased, you have no other option but to take the value that is the maximum, that is actually greater than the minimum possible value. So that's exactly what you're gonna do. You're gonna take out values. Which values would be? You're gonna take the minimum possible values. And what you would do is you take them and you add it some other place. But whatever the destination is, you will put each and every minimum values of other arrays into that same destination. What I mean by is that, for example, let's take an example, and it would be much more easier, I believe. Let's say I've got 1, 2, 3, and then 4, and then 5, and then 6. Now let's take this one too. 7, 8, and 9. You see that this is a minimum. So what you're going to do, you're going to take it out, and you're going to add it here. Let's, for example, just for example, now for this array, what you're going to do, you're going to take the minimum, and you're going to take it out. You're going to add it here. Now, what's going to happen after that? After that, what's going to happen is this will be erased. That one comes in here. This 4 is erased. Now that 4 comes in here. Now, when you finally go for finding out the value that you are about to find, which you have to do the maximum possible, you will get a maximum possible answer. Why? Because you've done something like that. You've taken out the minimum of the other arrays. So you know what's the minimum out of here. It's something that is greater than the minimum that you just recently took out. So 2 plus, it goes 5, plus, which one? The minimum possible values out of all the possible values that you're going to take out of all the arrays that you're going to take. So what I mean by is that your answer will always contain, you see that one? It will always contain a value at the end of the day that will be the minimum out of all the possible arrays values that you're going to take. Now that is a big thing for the final answer. You cannot just take that minimum value out, because no matter which destination you put, you always for sure have to add this minimum value. Now that is a very critical observation here. So what will be the final answer? The final answer will be, you will have always have a minimum value as your answer, plus what you're going to do is you're going to, let's say, possible arrays that I have. What you're going to do, you're going to sort each and every one of those arrays. So if you sort it, it's going to be easier for you to track those values, and you're going to take only the first two values. You're going to only deal with them. You won't have to worry about the rest of the values, because at most one value that you can take out. So there's no other way other than these two possible values that will contribute to the final answer. So you will take these values and you will add it inside a vector, maybe, you know, a pair vector, and you know what's the answer. Guaranteed answer is the minimum possible values out of all of these values, plus what will be the rest of the values. The rest of the values would be what are the other second, or should I say second smallest number of each and every other array's values. For example, if one was here, you know that it had to be, and it will always be the answer because it is the minimum out of all the possible values. But you also know that whatever the values, or whatever the minimum values that you've taken out of these arrays, they're also in here. So when you add values out of these arrays values minimum will be the smallest, the second smallest minimum value. And you know what these values are. The second value of the pair. Up until this point, of course, not this one, okay? Up until this point, you will add it. You have it, you will add it, and that will be your answer. Now, there's a catch. What is that catch? The catch is, how will you efficiently find out? For that purpose, what you have to do is simply, when you take the vector pair of the first smallest and the second smallest, what you're going to have to do is you're going to have to sort the values according to the second possible values of the vector pair, because that is the second that is going to be the second smallest number, 7, 8, 9. You wouldn't want the smallest possible value to come here. If it was here, doesn't matter, you take that out and you add it here. Where you're gonna add, now that is a big question that I actually want to dive into. What will be the destination array where all the taken out values are gonna be inside? What will be the destination value? That destination value will be the one array where the second smallest number is the smallest out of all the possible second smallest numbers of the arrays. What I mean by, if there was arrays where the second smallest possible numbers are 7, 8, 9, you would want your destination array where you're going to take all of those taken out values inside here, because that's going to ensure the maximum answer that you're going to get. Why is that? Because it's the smallest, second smallest number. And if you do that somehow, you know that these values are not, you will put that here, you put that here, you put this absolute smallest number in here. Then you can simply add these values and there you go, you get the maximum values. Now another possible catch is that, that's a slight edge case, I believe, is that what if the array value itself only one element left? What you're gonna do? Well, if there's only one element left, you won't have to do anything. You just add it to your final answer because you won't have to take out any values. That's simply not going to be efficient. So this is the edge case. If you take a value, an array having only one values, you simply add it with the final answer. You won't do any sort of operations. If you see an array of elements at least 2 or more values, Then for them, you're going to do those operations that I just talked about before talking about this. And for this part, always add it to the final answer. But for this part, you know how to do that because I just talked about it. So let's take a look at the code section, shall we? There you go. That's the code. You take the storage here. You're going to take the vector pair. You take those arrays, and you see that I just did the sorted part for each and every array. I just sorted. This is the checking for the edge case, whether that size is 1. If it's 1, add it to the final answer. And if it's not 1, if it's more than 1, then do what you're going to do. Always find the minimum because minimum is always part of the final answer. And you're going to also put it inside a vector pair. Why is that required? Because you're gonna sort it based on the second smallest number of each and every array. Now here's a tricky part. I just put the second smallest value at first and put the smallest value at second position. Why is that? Because I did not want to go for structure array. Instead, I wanted to go for direct array. As you know, if you sort a vector pair, what it's going to do, it's going to sort based on the first value and then based on the second value. But as I'm sorting values based on the second smallest numbers of each and every array. That's why I'm just swapping these values. I hope you get the understanding here. This is the check. If there is at least one value, one possible array where the value is more than one element, only then you do that part. This is for the part of this that I talked about, and this is the final answer. So this is exactly how you're gonna solve this problem. So I hope I made you understand this problem. Thank you very much for watching.